Jag tror jag drivs mycket av ren nyfikenhet. Också gillar jag drivning och transport. Men jag ser ett eller annat utmaning och där frågar jag hur fixar vi det här? För det här handlar om logistik, inte hypoteser. Vi ska leverera lösningar. Men det hjälper väldigt gott om man gillar själva verksamheten, drivning och transport. Jag gillar bilar, båtar och tåg. Ja, mitt namn är Dag Fjeld och jag är professor i skoglig logistik. Skoglig logistik i stor grad handlar om att säkra en jämn råvaruström till skogsindustrierna. Av de rätta egenskaper, allra helst till konkurrensduktiga priser. Det är så att i virkesförsörjning så märks det väldigt gott när vind och väder ändrar sig. Därför jobbar vi också mot mer robusta och konkurrensduktiga system för att få virke från skog till industri. I tillägg så är det så att för varje år blir industrierna större och större. Och då växer transportavstånden i takt med det. Därför just nu så är det väldigt stor fokus på mer kostnadseffektiv transport. Och faktiskt så är det så att miljöhänsyn och ekonomi, här går det hand i hand. Effektiv virkesstyrning, det kräver stenkoll på både resurser och virkesflöden. Skogssektorn det ligger i framkant när det gäller teknologisk utveckling. Alla de nya möjligheter som vi får från digitalisering, det tar vi gärna i bruk för att utveckla våra konkurrensfördelar. Jag vill uppnå 2 saker. Den första det är att kunna belysa nya möjligheter för en mer effektiv råvaruförsörjning. Och för det andra vill jag gärna förbereda våra studenter på att medverka aktivt i den utvecklingen.
Welcome, Dag Fjeld.
Thank you.
In the video, we could see a lot of clips where you were in dialogue with students. What does it mean to you to be in contact with forestry students?
Most of our specialized students, they go straight into wood supply positions. So we see teaching as a high impact activity. It's important to do it well. And also actually when it comes to an intellectual resource, normally when you put, say, 20, 25 students in a computer room, they can find a solution to almost anything. So it's sort of exciting too.
Mm-hmm. And what can you learn from students?
I've learned a lot. I mean, master students, they find solutions quicker. PhD students, they dig deeper. Insight, innovation, creative software solutions. Younger people, they're a bit quicker than we other.
Well, in the video you mentioned that environmental considerations and profitability go hand in hand in forestry logistics. How is that?
Yeah. As time goes, our mills get bigger and bigger. We have to move wood farther and farther. And basically it's easy. Trucks, they're high cost, high emissions. Trains, low costs and low emissions. Trains also use 1/10 of the energy the trucks use. So in the future, when we're moving farther out, when we're searching for cheaper solutions, they're actually more environmentally efficient as well.
Mm-hmm. But every log has to start its journey on a track. So how to overcome that problem?
Yeah, that's a problem. Realistically, we're looking to find broader rail solutions for a more overall effective system. We're not quite there, but we're working on it.
You're working on it. Thank you for now. Please enter the stage, Dag, and we will listen to your lecture. So I would like to introduce Dag Fjeld, Professor of Forest Technology, talking about forest logistics, smarter solutions for working in the woods. Please, Dag.
Thank you. Good afternoon, ladies and gentlemen. As Malin promised, a few words about forest logistics and smarter solutions for working in the woods. When you think about logistics, a lot of things come to mind. Generally, it's trucks, trains, boats, this basic transport technology, which does all the work. And the only thing we know that's sure about those is that as time goes, they just get bigger and bigger and bigger because it's more cost efficient. The difference now is that a lot of these solutions are fully digitized. You look at a logging truck, fleet management system knows exactly where the truck is, what it's doing, how much diesel it's burning. And even the latest rail wagons, of course they're getting bigger and bigger and stronger. But now the latest wagons have a digital sensor that tells you exactly how many tons are on the wagon, and most important, how many tons are coming to the mill when it arrives. But anyways, under the surface of logistics, there's a bit more. Basically 4 points we'll have a look at. What's it all about? The challenges, smart solutions, and a step into the future. So we'll start with what's it all about? Logistics is the practical calculations of getting wood from the forest to the customer. This is something that's going on for probably 500 years in Sweden, so it is fairly efficient. But the smart end of logistics is finding better solutions to practical challenges. And that's mostly about information flow and management decisions. It's also about the perspective on what we do. It's the supply chain we think about. And the goal is an efficient or an effective supply chain all the way. Alpha and Omega, that's secure, sustainable supply. And of course, we have to deliver predictable wood quality for the processes or products which the customer is going to refine, and always low costs, always seeking competitive advantage. So in relation to that, point 2, challenges. In principle, wood supply should be easy. You have a tree, follow the tree, and it becomes logs. Each log is tagged with an assortment. However, when you're going to do this with 80 million cubic meters per year, that becomes 250 million trees, 1,000 million logs. And somehow you have to get all these logs with their dimensions, their assortment numbers, and their qualities packaged together in about 1.5 million truckloads to the right customer. So it's not complicated, but there's a lot of stuff to track. It's complex. Over the real challenge. Wind and weather, public enemy number. When it's warm and wet, the supply chain bogs down. So in a picture here, you can see 3 years of data. 2014, 15, 16. On the top, you see the weather. On the bottom, you see wood supply per week. And you see some little blue lines jumping up. That's the snow. And if you look at the bottom, you'll see wood production following exactly the same patterns. We are dependent on weather. So high season, that's where you see these jumps up. On the far right, you'll see an area where the red, which is rain, jumps up before we have cold temperatures. That's the nightmare scenario, and production drops. And the worst thing is that weather, it rarely repeats itself. So we're faced with finding a way to manage both complexity and unpredictability. And the general idea is to have a long-term perspective with constant short-term planning. And there's always a structure there. We start with our long-term strategic goals, sourcing, system development, work down to planning of flows and stocks, before we get down to management, harvesting and transport, keeping flows on track. After that, it's just the issue of synchronizing the supply chain. There's a lot of people, machinery, flows, and logistics is sort of like being a choir director. Somebody has to keep the pace, the beat. Planning, execution, control. Because the whole supply chain has to work after that. So typically when we work with the students, we're trying to explain this, I say, well, you know all those small tropical fish that are down in the Mediterranean? They swim in each direction, do what they want. If you want competitive advantage, all those fish have to come together and act as one big shark. It has to be coordinated. And then you have competitive advantage. Point 3, some smart solutions. Just 2 examples. One thing which we've actually succeeded quite well with, and something else which we are not quite there yet. Work in progress. In the picture here, you'll see tools for flow planning, which is basically which wood we sent to which mill. And what you see on the left is a visualization of exactly where the wood is coming up every week, every region and district, which is basically like a video game. You can scroll through a whole year and exactly where you have the wood at the different times. And based on this very dynamic situation, you can go to the right-hand picture, click a button, and in 60 seconds you have an optimal supply plan of where the wood should go. Which is actually 60 seconds. That's pretty good. The math's not that tough. We have new optimization solvers, so you can actually run it in Excel, which everybody's used to working in. The problem is you have to get the data in. It's a question of plugging in the right numbers, getting them in quickly, and that's about digital infrastructure. So that works. Something we're still working on. Log truck routing. Where do you drive the truck every day? Where do you pick up a load, drop it off, pick it up, drop it off? Theoretically quite complex. There's over 1 million alternatives just for one day. We have some good prototypes made by different researchers, but they require massive amounts of data to solve these problems. But in practice, the really experienced operators, they do this up to 95% of the optimum every day. Question is, how? We researchers can't crack this. Why can they do this so well? That was a question I had. So as usual, a master's student who wanted a tough job got that question to answer. And he found out that basically what they do is they just break down the problem in 4 steps and progressively reduce the complexity according to priority, feasibility, and efficiency. And then finally, there's just a few alternatives left, good ones. Smart and simple works in the woods. The student, Jonas Lindström, he also showed the effects of the way we work on profitability and service. So there you see profitability, service, and you see one group of people working with a smart model and some people working with a less developed model. For the smart model, you see a nice trade-off between profitability and service, like it normally is. And you see this other group, maybe the same profitability, but they can't get the service. So a lot of this is about the challenge, of course, is improving operations and changing our way of working from a limited model to a smarter model and keep developing these smart models. That was a bit about challenges and solutions. Point 4, stepping into the future. New opportunities, new challenges. One of those is climate. It is getting warmer and wetter. If we look at the graphics here, we see Finland in January of 2001, 2012. And the amount of days in the middle of the winter where the roads should have been frozen. The red is a problem. When it's soft, we can't move wood, and then things stop. So we have these challenges that are arriving. We know we have to fix. So if I was going to be very general, I'd say here's the future. Resilient industrial supply chains. Always up to date on operating conditions. Control our capacity of wind flows. But most important, built-in structural flexibility and contingencies for all these disturbances we used to have to handle, both in supply and demand. And of course, new digital technologies, they'll shape our future supply chains. We have lots of data on forests, roads, supply chains. But what we need is the digital infrastructure to connect this, if we want the insight and the more efficient management. I think we used to say the sky is the limit. Now I'm hearing more and more, the cloud is the solution. Well, it's going in that direction. But regardless, the bottleneck for future development, that's our capability to innovate our processes, our ability to change the way we work. So, I think in the future, SLU has plenty of work. All the way, research, development, dissemination, and training, the final step to success. Thank you for your attention.
Thank you very much, Dag Fjeld, and welcome back to your seat again. I would like to remind you in the audience that you could send questions to Dag to niaprofessorer@slu.se. So, welcome back, Dag. Thank you very much. The wood supply chain is long, with many steps from the forest stand to the industry gate you just showed us. How do all these links work together?
Well, they actually work quite well in a tight supply chain. The whole chain sort of swings to the same beat for a good chain. First step is acknowledging how your own role influences others. And after that, just a question of coordinating all the different steps.
Mm-hmm. It sounds quite simple. I was just thinking about the link, the people in different links. What can you say about their? Are there any bottlenecks when you're speaking about people in this chain?
Yeah, it's. I think it's important that. It takes 20 years of experience if you're just going to do it at work. Mm-hmm. But especially for long, complex chains, the issue is actually understanding how whatever you do influences the others. So with students, it's quite simple. We use virtual training arenas. Mm-hmm. And we start them up on simple scenarios. We can run a whole year in an hour. And you make tougher and tougher scenarios. And then for each game, the students have to work out how they're going to improve their coordination and performance. So it's just training, basically.
Okay.
But the first issue is understanding how you yourself influence the whole chain.
Mm-hmm. Yeah, of course.
And there is... this work started at MIT in the 1960s. Jay Forrester and John Sterman. So you can actually quantify how people act in this context. That's something we do with students.
And what about
And I think this.
sorry. No, I was
Go ahead.
thinking about the operational everyday work. How can people learn and improve in that context?
I know a lot of the companies have scenario exercises. What if? But they're always looking ahead, saying, if this happens, what do we do? Where do we find the limits for the organization? And it would be interesting also if everybody to the same degree had follow-up exercise. What did we do this year? We look at, okay, this happened, great opportunity. How do we exploit it? This happened, risk moment. Did we fix it? Did we not fix it? We succeeded, okay. Remember that? We didn't succeed. We'll have another go at that.
And what can
So
we
I
learn?
think, but it's not that popular to look back at what you did. It's sort of more popular to look ahead at what we should do. Both ways are needed, I believe.
Yeah, thank you. We have a few questions for you, Dag. Logistics seems to be a combination of mathematics, IT, forest technology, economics, etc. What fields are most important for being a successful professor in this area?
Oh goodness, you have to have them all. But you can never be. I mean, an expert in IT is an expert in IT, and regardless of what you do, every logistics project results in a new IT solution. So even as foresters, we can't hide from the world of IT. We actually have to ourselves be fairly competent on these issues. So most important, I mean, if you ask a mathematician, that's most important. But having an overview, and like I said, the bottleneck for development, that's the way we work. So we have to understand how companies and the supply chains actually work. That's where we start.
Thank you. What is your own background? I forgot to ask you.
Forester.
Forester?
Canada, 87, UBC.
Okay.
But I'm working on logistics since about, I guess, the 90s.
I see. Another question here. Are the challenges to create smart solutions the same or very similar in most parts of the world? Or are there essential differences? Is Sweden unique in any way?
Yeah, the Nordic countries, which Sweden, of course, is a big part of, we have our operational conditions. And again, the weather. We use the winters. We try to survive the summers. We have the platform of IT is more advanced here in many countries. You have a sector-wide infrastructure, biometry, SDC, which we can build as a springboard for almost anything. And when it comes to infrastructure, physical infrastructure, rail, roads, it's pretty good here. So if you can't succeed here, you can't succeed anywhere.
Okay. Another question. Wood supply is weather dependent. Climate change tend to make weather more and more unpredictable. To what extent is this taken into account in the development of new wood supply chains?
When it comes to the whole chain, everybody has to be prepared for less predictable seasons. So that's the basic thing. It's tougher when you don't know what's coming and you have to be able to quickly replan, find new harvesting areas, use these roads. And a winter with no frost or just varying frost, people have to be on their toes all the time. So it is tougher, but there's a lot of new opportunities to get new insights, connect data, figure out how to do it. Work in progress.
Well, another question from me, and it's like another topic now. How could the university contribute to accelerating innovation in the forestry sector?
I think, like I mentioned before, the most important thing is that academia has to always be aware of sector challenges. We have to be right there. And as long as we're up to date on that, we listen well. That means our energy and creativity is focused on the right issues. After that, it's just hard work.
So how close collaboration are you and your colleagues when working with improving the logistics in the supply chain, wood supply chain?
Well, for us, it's pretty easy because we work with technology, and everybody out there has the same interests. So it's easy to pick up the telephone or send an email or receive an email. We speak the same language. So I think it's business as usual.
Yeah, you speak the same language. And with that, I would like to thank you very much, Dag Fjeld, the last professor of the day. So thank you very much.
Thanks. Nice being here.